What's up, everyone? Welcome back to Data Sciencey. If you're a tech geek like me, you know CES is the stage where tech giants flex their muscles, and Nvidia just blew the roof this year. Jensen Huang brought some groundbreaking announcements, and trust me, you don't want to miss it. So let's dive in.
Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks.
All right, first up, the GeForce RTX Black Series, built on NVIDIA's Blackwell architecture. These GPUs deliver double the performance of the RTX 40 series. Double. That's absolutely wild. And this GPU, it has 92 billion transistors and it delivers 3,352 trillion AI operations per second tops. And here, even Huang said that the mechanical design is also umbilical. He also states that the graphics card has 2 cooling fans. For gamers, this means smooth 4K gameplay at ultra settings. For creators, whether you're rendering complex 3D scenes or editing 8K videos, it's about to be a whole lot faster. And ray tracing? Nvidia keeps pushing it to photorealistic levels. Gaming, creating, or developing RTX 50 is going to redefine how we work and play. Even if you look at the video of this, the gameplays, they look so ultra realistic and amazing. By using this GPU, you could get a boost to your gaming.
Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. and the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics.
Next up, physical AI. So, this is where machines stop just being smart, they start being capable in the real world. So, physical AI is all about giving robots and devices the ability to perceive, adapt, and also interact in the environment like never before. Imagine a warehouse robot that can pick up and sort packages, and it avoids obstacles in its path, and also it learns from the new scenarios. Or imagine there's a robot which is a surgeon that adapts in real time to a patient's unique anatomy during surgery. And so physical AI is actually bridging the gap between the virtual and physical worlds, which will enable robots to truly understand and react to the world around them. So it has massive implications for industries like healthcare, manufacturing, logistics, you name it. The future isn't just about AI thinking smarter, it's about AI doing it smarter. And that's where Cosmos comes in. So, Cosmos is a universe, it's not just a tool where the AI can learn, grow, and evolve. So, Cosmos is actually the virtual world for the physical AI, means for robots, for smart driving cars, for everything. It's a virtual world in which the robots will actually learn it in the virtual environment so that they can be ready for the real world. Cosmos is NVIDIA's groundbreaking simulation platform, which is designed to be the ultimate training ground for AI systems.
We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world.
Cosmos is like the ultimate toolbox for building world foundation models. We're talking about the auto regression model. Then, after that, there's the diffusion based model. There's the cutting edge video tokenizers, and of course, the NVIDIA CUDA video processing pipeline to make it run smoothly. And here's the cool part, you can feed Cosmos using the text, image, or video. Then it will generate these incredible virtual world states as videos. As you can see here, some more examples are also given. So it's not just about, making pretty simulations. It's designed with the real world use cases in mind. If you think about the autonomous vehicles, robotics, and other scenarios. And here, what developers do, developers use Omniverse to create the accurate physics based simulations, and then they plug those into Cosmos, which generates the photorealistic and physically accurate synthetic data. So it can be like changing weather, time of day, or even like the diverse objects. Cosmos has you covered.
Most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. It's a AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools, it might be using a calculator, and it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. And I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs.
NVIDIA partnered with Toyota to power up their next generation autonomous vehicles. So these cars are learning how to handle everything from busy city traffic to tricky road conditions in real time. It's not just about making cars drive themselves, it's about making them safer, smarter, and better integrated into our daily lives. So if you imagine a car that knows the fastest route, predicts traffic patterns, and adjusts on the fly. So, for that, Huang announced the new Nvidia AGX Thor system on a chip, which I'll be showing you the video now.
Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer.
Let's wrap up. What do you think about these announcements? Are you hyped for the RTX 50 or is physical AI blowing your mind? Let me know in the comments below. And don't forget to like, share, and subscribe for more AI news from data science. Catch you in the next one. Bye bye.